Okay, so now that we've done step one and step two, right? And it doesn't matter which order you do this. You can find the horizontal component first and then the vertical, or find the vertical component, then the horizontal. That doesn't matter. But once I am done now, I can see overall this hot air balloon is going to end up going the direction to the left and up. So it's going to be more like a northwest direction, okay, is the direction that this hot air balloon is going to go. Okay, north and over to the west. So I'm going to come over here for step three, and I know that I'm going to go in this direction, up and to the left. Okay, so I went ahead and drew a vector arrow that shows that. Now that I know that overall this is going to be the general direction that my object's going to travel, I'm going to go ahead and draw out my X and Y chart or graph. Okay, so I have my X component, my Y component, and I know that the hot air balloon is going to travel in this direction because of my horizontal and vertical vectors over here. Okay, now it tells me here, find the net force of the overall magnitude and direction. Don't forget, in this classroom, when we say direction, we mean theta, right? So if this is where my hot air balloon is starting and it's traveling this direction, remember, what did I tell you on the last unit? The tail end is where your theta is going to be. So my theta is going to be right here. I'm looking for that theta, and I'm looking for that leg. Those are the two things I'm looking for. Okay? Now, they gave me some information, though, or I was able to solve a little bit. I was able to solve the X component, which is this leg right here, and it's going to be 570 newtons. And the Y component, which is this leg right here, is 1,070 newtons. What does this create? I can see that there is a 90-degree angle over here. I have a theta. I see that I can SOHCAHTOA this. How do I do this? Remember, same steps as we did last unit. Here's my right 90-degree angle. Draw an arrow. This is my hypotenuse leg. Here's my theta and my 90 degrees. This is my adjacent leg, and this is my opposite leg. Okay? Now that I've labeled it, I'm going to come over here and I'm going to write SOHCAHTOA. What do I have, and what am I looking for? Okay? I'm looking for this leg over here. In this case, since I have two legs, I can go ahead and I can Pythagorean. And since that's a hypotenuse, I can say a squared plus b squared equals c squared. Or I can SOHCAHTOA this. Your choice, okay? But when it comes to the theta, you have to SOHCAHTOA. Okay? So I'm going to go ahead and do the theta first. Okay? With this theta, I'm going to say, well, I have this leg and I have this leg. I have the O and the A. Who is O and A? That's the tan. So the tan of the theta equals the opposite leg over the adjacent leg. Or the tan of the theta equals 1070 divided by 570. Okay? And when you have your calculator out, what are you to do? You are to make sure that that sucker is going to be in degrees and not radians. Okay? Degrees and not radians. So I'm going to come over here. I'm going to say, well, 1070 divided by 570 comes out to the tan of the theta equals 1.88. Not my answer. Remember, like square and square root, we have to do the opposite. We're looking for this theta. We don't have it, so we do the opposite, which is the inverse. Remember that second key tan? And once you do that, you're going to find out that the theta equals 61.99 degrees. Okay, 61.99 degrees. Now that's only the first part of my answer, so part 1. This is a 2-step problem. Part 2, your choice again. You can either SOHCAHTOA to find the other leg. Since this is my hypotenuse, a squared plus b squared equals, this is a c squared leg. I'm just going to go ahead and do that for those of us who like it. Like I said last unit, I personally don't like it. I'm just not a Pythagorean kind of person, but some of you are. So let's go ahead and do that. Let's say 570 squared plus 1070 squared equals c squared. So let's do the 570 squared comes out to 324,900. 1070 squared is 1,144,900 equals 1,469,800. Not my answer because this equals c squared, and I have to do the opposite, which is the square root. So my hypotenuse leg, or my magnitude, comes out to 1212.35. You need to keep the SI unit, which is in newtons. So 1212.35 newtons is your answer. Okay? Not too bad. Okay? Plus, this is something that we've already done last unit, so I really believe that this unit's a little easier for some of us. We're really going to start getting the hang of it, and we're going to be successful on this next test. Let's go ahead and practice again. We've got a little bit more practicing, and then we get to a new equation. Okay? So we've got question number 2, question number 3. Let's go ahead and let's look at question number 3. We can always at least set it up or go over it here. We can go over it in class, but I'm going to go ahead and at least kind of set up question 3 for you. It says here that a 2406 kilogram crate, that's a mass number, is pulled to the right with a force of 82 newtons. So this mass moves to the right 82 newtons. To the left with a force of 115 newtons. So this mass also has a leftward pull also. It has an upward force of 565 newtons. Find the weight force of this crate on the ground. So that's question number 1. Question, find the weight force of this crate. The equation for force equals M times A. Now, when they say weight force, then it's kind of like how we have our, right here, weight force. And so we write it with this type of F with a little W. So F sub W equals M times A. Okay? What is the mass of this object? Well, the mass they told me was 24.06 kilograms, which is correct. We're going to multiply that by acceleration. What is the acceleration? Well, wait a minute. Let's go back before we get all fluttered. Yes, it's moving to the right, it's moving to the left, and it has an upward pull. It has 3 pulls on it, but it also has the pull of gravity down on it. And the definition for weight is the gravitational pull on a mass. Okay? So, what is acceleration? 9.81. Yes, I understand it is a negative because of direction, but I leave the negative out. My answer comes out to, let's go ahead and do that. I don't have that answer here. 9.81. Multiply that by 2406.06 comes out to 236.0. I'm going to round it to 3 newtons. That's the weight force for this crate. The next question. Draw a free body diagram correctly labeling the normal force, the frictional force, the weight force, and the applied force. We can do that. In the directions over here, this is what they were talking about. Okay? It says here, draw a box or draw the object, including all of the arrows. Label the vectors that are applying to it or the forces and include what type of force. That's what this was trying to talk about. So let's do that over here. I'm going to draw a box. Either number one, you just draw the box, or number two, you actually draw the object. And the object still happens to be a box. The next step is we draw a dot in the center of it, and our arrows come from the center moving outwards. That is the correct way. Yes, on some of the homeworks or quizzes, you may see arrows that are not starting from the center moving out. That's okay. We know how to do it the correct way. So what is the downward pull? The downward pull is the frictional weight force, or the weight force, and we just calculated that to be 236.03 newtons. You must include the magnitude and SI unit if you know it, and we know it. Now look, it told me that it's moving to the right and to the left and upwards. It's moving to the right, 82 newtons. To the left, 115 newtons. And upward force, this is my weight force, okay? An upward force of 565 newtons. Now, I should have maybe did this in a different color. Let's do that. Just so that way you can see this, because this is new to us. Since we know the direction, we must put the direction. Since we know the magnitude, which is the number, we need to include it. We know the SI unit, we need to include it. But we also need to label the type of force that goes with that vector. This vector is a weight force. And it says label those two forces. So I did that one. Now I have a normal force, a frictional force, and an applied force. The normal force is going to be almost always opposite to the weight force. It's the force, if my object is sitting on the ground or sitting on an object, sitting on something, it's the force that holds it up. And it told me this crate is on the ground. So we don't draw the ground or the concrete or the sidewalk, but it's there. And that's what's holding this up. So we're going to put on here, this force is the normal force, F sub N. Now I have applied and frictional. Applied is the direction that it's moving, and friction of force is the opposite of the applied. So between those two arrows, this one is the bigger arrow. The F sub A goes over here. The F sub F, frictional force, goes here. Now we did this one and this one. So this is the correct way. Draw the box or the object, put a dot in the center, have all of the arrows coming out from the center of the dot, include magnitude and the SI unit, and include the labeling of what type of force that vector is. All right, now let's go ahead over here. Find the net external force in the X direction. What would be X direction? Horizontal. What would that be? Well, that would be horizontal. Here's my two horizontal. 115, take away 82. Okay? So that way we can find the horizontal. So 115, take away 82, comes out to 33 newtons. What is the Y direction? That's the up and down. Those are 565, take away 236.03. Remember, we don't want a negative value. 565, take away 236.03 equals 328.97 newtons. Let's keep going. It says here, find the magnitude and direction. When they say direction, they mean the theta of the net external force acting on this crate. So let's go ahead and let's look. Between the horizontal right and left, who's going to win? The left. I'm just going to put right here, the left. Between the vertical up and down, who's going to win? Up. So my object's going to go up and to the left. So my object's going to move in this direction, a northwest direction. And here's where it started off at. Okay? So here's how we do letter E. Let's get ready. Now that I draw the overall direction that my object's going to travel, I'm going to do my Y and my X on my graph. And I see that there is a theta right here that I'm looking for. They gave me the horizontal vector. So horizontally right here, that is 33 newtons. They gave me the vertical, or I found the vertical, which is 328.97 newtons. I see that there is a right angle that's produced. This forms a triangle. I'm going to SOHCAHTOA this. SOHCAHTOA. Let's label, okay? Just like we did last unit. I'm going to draw an arrow from the opposite side. This is my hypotenuse. Here's my theta and right angle. Here's my adjacent. And here's my opposite leg. Okay, I'm going to go ahead first and find my theta. What did they give me? They gave me this leg, the adjacent leg, and they gave me the opposite leg. So who is adjacent and opposite? The tan. So step 1, I'm going to say the tan of the theta equals the O over the A. Or the tan of the theta equals 328.97 divided by 33. So let's go ahead and do that. 328.97 divided by 33 comes out to the tan of the theta equals 9.97. Again, that is not my answer. I need to do the inverse of the tan, right? So let's do that, -1. And my theta comes out to, let's go to mode to make sure, yes, clear. Second tan, 9.97, close parentheses, 84.27 degrees. That's part 1. Okay, let's do the other part. The other part is finding the hypotenuse leg, right? Finding this leg right here. So I'm going to come over here. I'm going to write part 2. And again, your choice. You can SOHCAHTOA or you can Pythagorean. A squared plus B squared equals C squared. 33 squared plus 328.97 squared equals C squared. So this comes out to 1,089 plus 328.97 times 328.97 equals, this side comes out to 108,221.26 equals C squared. Let's add those two numbers together. 1089 equals 1093.10.26 equals C squared. And we know that's not our answer. We have to do the opposite, which is square root it. So let's go ahead and square root that. 1093.10.26 equals 330.62. newtons. And you know that when you find the hypotenuse, or the hypotenuse leg must be larger than both of those legs. This leg is 33. This leg is 328.97. And the hypotenuse, they told me, is 330. It's not much bigger, but it is bigger. Perfect. Okay? So let's keep going. There is another practice problem over here on number 2. I have no problem with us next week going over this together in class, okay? So if you remind me, let's go ahead and we can definitely do that part here in class. Let's keep going to our new part over here. The next part here is Newton's law of gravitational equation, okay? So it says here, Newton says that universal refers to everything. So Newton's law of universal gravitation. And he used the word universal because he was literally talking about everything in the galaxy, everything in our solar system, everything that exists regarding matter, though. Okay? It has to be matter. The law of the universal gravitation states that all objects in the universe with mass exerts a gravitational force on each other. It says here that the strength of the gravitational pull between any two things depends on their, number 1, mass, and number 2, the distance between them. Okay? The bigger the mass, the stronger the gravity, or the gravitational pull. The closer the objects are to each other, the stronger that gravitational pull. Let's keep going. It says up here at the top, right? Remember Newton's third law says for every action there is an equal and opposite reaction. This means that object number 1 pulls on object number 2 with the same force that object 2 pulls on object number 1. This has an equation. Let's write this equation down. F sub big G, and it is a big G because big G is different from little g. Little g is negative 9.81. Big G is a different number. Equals big G times m sub 1 times m sub 2 over d squared. Okay? It looks like a crazy equation. It really is not. It just has crazy big numbers. Okay? This equation also can be put into the triangle. Okay? If you like the triangle, if you do, I'm going to come over here. How do I put things into the triangle? You cover up the equal part and you put in what they have. And what we have over here is being divided. So the G, the M1, and the M2 have to go at the top of the triangle. The D squared goes anywhere at the bottom. And what's left over is F sub big G. So that's how you put it into the triangle. Okay? Now let's keep going. There are 1, 2, 3, 4, 5 variables that we have here. I am so sorry that this has a little g. This should have been a big G. So F sub big G, make sure you go in and write that as a big G, equals the force between the mass. The masses. I'm going to say masses, right? Because there's two objects. The SI unit is a capital N for Newton. Big G stands for the gravitational constant, which is a number, kind of like how last year you memorized Avogadro's number. This is a different number. This is Newton's number, Newton's gravitational number of 6.673 times 10 to the negative 11th power. It has an SI unit, which is a Newton meter / kilograms square. Okay. Mass M1 is mass of object number 1. Yes, it's in kilograms. M2 is the mass of object number 2. Again, it's in kilograms. And the D stands for distance between, here's the key part, the centers of the two masses, the two objects. Remember when we first, like maybe it was unit 1 when I talked about measuring with the ruler, you always measure from the center of one object to the center of another object. This is the reason why. Because in this equation, you measure from the center of whatever object to the center of the next object. It's not from this end to this end of the object. It's not from this side to this side of it. It is from the center to the center. Okay? So let's go ahead and practice a little bit, okay? Let's do this practice problem, and then we can do the other two in class. Again, though, you're going to just remind me, hey, Miss Munson, you said you were going to practice a couple of those in class. They're not difficult at all. Okay, please make sure you know how to type it into the calculator correctly. That's where I do see some problems. Let's look at this one here in the middle. What is the gravitational force? Question mark. F sub big G of the sun and the earth, the sun on the earth, if the mass of the sun is, here's my M1, and the mass of the earth is M2, and the distance between them, again though, from the center, is this. Show your work. Some of us haven't been showing our work in our notes. Just because you watch my videos, you're going to just sit there and plug in the answers. So some of you are wondering why you're getting points off your notes. That's the reason why. You continue that, I promise you I'm going to continue to take off the points. On your homework, if you continue just to put in the answer, and that's it, and not show me your work, again, I'm not going to give you full credit. Some of you are making 50s on your homework papers because you're just giving me the answers only. Again, I'm not a teacher who's going to sit there and tell you, you have to do your math my way, okay? I agree that math can be done more than one way. Show me how you did your math, not just give me the answer that you Googled off the internet or you got from somebody, okay? So yes, you're going to continue to get those 50s because you're not showing me your work. Let's show the work on this problem. The equation is F sub big G equals big G times M1 times M2 over D squared. What am I looking for? I'm looking for the gravitational force. Do I need to rearrange this equation? No, I don't. I can leave it as is. So let's do that then. Let's put Newton's gravitational constant of 6.673 times 10 to the negative 11th, multiply it by the mass of the sun, 1.99 times 10 to the 30th power, multiply it by the Earth's mass, which is 5.98 times 10 to the 24th power, divided by the distance between them from the center to the center, 1.5 times 10 to the 11th meter, but wait a minute, square it. Okay? this was me, I'm going to go ahead and get this number and square it first and get a number down here. Then I'm going to multiply those three numbers and get a number up here. Then I'm going to divide them. I know some of you like to just go ahead and plug them all into the calculator at one time. That works too. I'm just not that kind of a person. I like to do step by step so I can see where, if I'm going to make a mistake somewhere, okay? So here's where I do see problems. Please make sure you use parentheses. That is going to be your goal. So parentheses 1.5 and times 10 to the 11th power. You know that you do not actually hit the multiplication key. That does not work. I personally like to hit the second key, comma, where I have that little E. Some of you like to do another way with the housetop. You're more than welcome to do that way also. To the second power, parentheses times, open parentheses, 1.5, second key, comma, 11. And look at this. Why did I put a 2 over here? I'm going to clear it out. 1.5, second key, comma, 11, parentheses, 1.5, second key, comma, 11, parentheses, equals, okay? 2.25 times 10 to the 22nd power. Multiply the three numbers at the top. Again, I'm going to make sure I use parentheses around all of them. 6.673, second key, comma, negative 11, parentheses, 1.99, second key, comma, to the 30th power, close parentheses, parentheses 5.98, second key, comma, to the 24th power. Alrighty. So now I multiplied all three of those numbers and I got a number here of 7.94 times 10 to the 44th power. Okay. Now again, I'm going to go ahead and make sure I use my parentheses. 7.94 second key, comma, to the 44th power divided by, open parentheses, 2.25 second key, comma, 22nd power, close parentheses. I get an answer of 3.5, and I'm going to round it to 3 times 10 to the 22nd power. Hold up. Make sure that you use the correct SI unit, which is a Newton. There we go. Not too bad. Alrighty. I feel confident that we're going to do good in this unit. Okay. Our notes are done.